Okay, so we are ready to get rolling. And our speaker for tonight is Dr. Dale Leckie, who is a geologist, speaker, and best-selling author who worked at the Geological Survey of Canada and as chief geologist at Nexen. I hope I'm pronouncing that right. A large Canadian energy company. He has edited numerous books and published widely on the geology of Western Canada. He is an adjunct professor in the Earth, Environment, and Energy Department at the University of Calgary. Dale has been recognized for his long-term contributions to geology and is an honorary member of the Society for Sedimentary Geology and Canadian Energy Geoscience Association. Dale is the 2024 recipient of the Geosciences in the Media Award by the American Association of Petroleum Geologists for his first two books. One of which was Wildlife, Landscapes, and Geology, an Alberta and Saskatchewan touring guide. Which is the third of his best-selling trilogy of books, encouraging people to get out and explore. Dale's previous books include The Scenic Geology of Alberta and Rocks, Ridges, and Rivers, which were both bestsellers. I've got the first volume of that series, and I can tell you it's definitely worth reading, and definitely will be going out to complete my collection. So with that, I will turn it over to our speaker. Please take it away.
I'll just ask the question. Can you see the screen there, Nick?
Yes.
Okay, very good. Well, thank you very much, Nick. Thank you to Nature Alberta. Thank you for everybody for showing up tonight. What I want to do today is talk about wildlife, landscapes, and geology, exploring connections. And what is the premise of that title of the book that I wrote? So here's a landscape photo, or not a photo, but a landscape piece of art by Dean Francis. It's the South Saskatchewan River in southern Saskatchewan. And it's like a photograph. It encapsulates so much about what I like to explore, what I like to see, and what I'm going to talk about here. So what have we got in this landscape, in this picture? What we've got from a geological or geomorphological perspective is up on the top, there might be sand dunes. You can see way in the distance, glacial lake deposits. The banks of the South Saskatchewan River Valley, lots of badland topography. Then we've got the river. It's a meandering river, and there's those words that say pool and riffle. You can see along the margins of the bank and the point bar, there are a lot of trees and cottonwood forest. So how does that translate into wildlife, which is what I'm talking about? If you have sand dunes in the prairies, and we have a lot of sand dunes, you might get kangaroo rats. In the badlands, prairie rattlesnakes. Up on the more level parts of the prairies, on the glacial lake sediments and the rolling glacial deposits, you get bison, pronghorn antelope, burrowing owls, snowy owls. And then you've got the cottonwood forests lining the river valley and the deep river valley, and we'll talk about that. And in those cottonwood forests, they provide, I call them prairie oases for birds. And that's why I've got birds, birds, birds. And in the rivers, lake sturgeon, that are their habitat is closely related to those words I had, pool and riffle. So that's what the theme of the book is about. And that's what I try to encapsulate in this picture of Dean's. So our outline today, excuse me, is we're going to talk about rugged mountain cliffs and safe places. We're going to talk about wildlife of the dry rolling prairies. We're going to talk about rivers crossing the prairies, deep valleys, cottonwood forests, and prairie oases. You start with the rugged mountain cliffs and safe places, and maybe you can imagine what I'm going to talk about now. So one thing that most people don't realize is that the Rocky Mountains are not being formed anymore. They are eroding, and they've been eroding for the last 60 million years. They're eroding to give you the tremendous landscape features that we see, these steep, rugged cliffs, and then the debris below them. There is the eroding mountain. This is Crowfoot Mountain, just south of Bow Lake in Banff National Park. And you can see a bunch of words there. Talus slope, that's the debris from the mountains. Large boulder, rock falls, debris flows, alluvial fans, end moraine, glacial cirques. But it's all contributing to the erosion and the creation of that landscape. And those steep, rugged slopes that you see there, the top of the mountain, there it provides rugged slopes that provide habitat and protection for a lot of wildlife. And then, as I mentioned, the Rocky Mountains are eroding, and they've been eroding for 60 million years. Well, how do mountains erode? If you go to Jonas Creek Rock Slide in Jasper National Park, about 500 to 1,000 years ago, there was a big landslide. And the debris from that landslide, that rock fall, ended up in the valley bottom like this. And the road crosses all this debris from that rock slide. And that creates habitat for American pika. It creates habitat for hoary marmots. So you can see the eroded debris provides habitat and protection for these smaller animals. So mountain goats, mountain goats, where are you going to see them? On those steep, rugged cliffs. So there's a good chance that I and many of you would never be able to get to the mountaintops or to go climbing the mountains to see them. So where can you go to look for mountain goats? So I call this the mountain goat and lake bottom treats. So here's a mountain goat. And if you want to see mountain goats, where should you go? That's what we're talking about right now. Well, what my argument is, let's go check out the local geology. So mountain goats do live in the remnants of those eroding mountains. They live and inhabit some of the most rugged terrain in Canada. And as I said, a lot of that rugged terrain, most of us will never be able to get to. You might see them with a good photographic lens or a good set of binoculars, but there's other places to go look for mountain goats. Glacial lake beds, which the mountain goats go to for minerals, for nutrients. So mountain goats do require mineral nutrients, just like we do, and they'll travel considerable distances to get to them, quite often at risk or hazard to themselves and to their offspring from predators. They'll come down off the mountain cliffs, go into the river valleys, looking for minerals. So where are we going to go? Let's go to Mount Kirkeslan Goat Lick in Jasper. It's along the Athabasca River, along Highway 93, and it's easily accessible. 12,000 years ago, the glaciers were melting. And prior to 12,000 years ago, all those valleys in Jasper, Banff, were filled up with large valley glaciers. So the ice started melting 15,000 years ago, 20,000 years ago, 12,000 years ago, more or less. There was a valley glacier which went down the Mayette River, dammed up the Athabasca River near Jasper. That created a large glacial lake Kirkeslan. So the ice was melting. You had a dam created by ice from a larger valley glacier, and it created this large lake. And what was happening is meltwater loaded with silt, rock flour, you might know it as, was flowing into that lake. And so if you've been into the mountains in the spring, early summer, you'll see these streams that are almost white as they carry glacial flour, silt and clay within them, like we see here in Hilda Creek. Well, that silt and clay flows out into the lake, and it lines the bottom of the valley. So the valley glaciers, they eroded minerals from limestones and dolomites that are all in the mountains all around there. And then they carried those minerals as rock flour into the lakes. Some of the minerals, and there's lots in there, phosphorus, sodium, sulfur. There's a picture from the Mount Kirkeslan Goat Lick, and you can see about a 9-meter thick bench of these glacial lake silts. That's what that material in the bottom half of the photograph is. And you can see way off in the distance, within the dashed yellow line, that's part of the lake bottom as well. It extended up and down the river valley. So geology and mountain goats. So for each of these topics, each of these animals that we're going to talk about, there is a relationship between geology and whatever the animal is. In this instance, the geology that we're looking at is the remnants of those eroding mountains. Tens of millions of years of erosion has been taking place to leave the steep, craggy mountain cliffs that the goats breed and spend much of their summer on. And then the glacial lake beds, they provide mineral nutrients. For each of the animals, I've got a slide like this, but I'm not going to review it. Just going to remind you about the relationship between geology and whatever animal we're talking about. Let's stay in the mountains, American pika or pika, and mountain debris. Pikas live up at about tree line, and their habitat, as I mentioned a little while ago, is on is the debris of eroding mountains. They live close to mountain meadows, which they need for grazing, for their food source. The interesting thing about pika and related to the geology is they migrated into North America about 500,000 years ago. They extended as far south as California. The name pika originates with the Tunguses people out of southeast Siberia. Whenever the earth underwent a major glaciation, as most people know, sea level fell. And because the water from the oceans was taken up by the massive ice sheets around North America, Europe, and in parts of the southern hemisphere. As a result, sea level dropped. What happened then is animals would migrate from Eurasia into North America, into Alaska, by what we call the Bering Land Bridge. That is how the pika made its way into North America. As everybody knows, if you've been in the mountains all summer long, pikas are harvesting the local vegetation. They store it for the winter. Pika do not hibernate. They stay under the snow all winter long. They depend on their hay crops, which usually are not enough, and then they'll branch out. They'll dig tunnels in the snow to eat the alpine vegetation from the mountain meadows in the area. So there's the relationship between geology and American pika. The soaring golden eagle and mountain thrush sheets. Golden eagles, they migrate every spring and fall, thousands of kilometers. In the spring, they migrate from down in central United States, almost Mexico, northwards, making their way to the Yukon territories and Alaska. In the fall, they go the opposite direction. So thousands of kilometers. Where do they migrate? Well, if you take a look at our mountains, and their migration route is dependent on these mountains. So our west dipping mountain ranges, remember we said they've been undergoing 60 million years of erosion to give us a fantastic shape that we see when we go visit the mountains. Here's the Athabasca River Valley coming out of Jasper National Park. And what those mountains do is they all dip to the southwest. Those thrush sheets or mountain ranges dip to the west and to the southwest. Prevailing winds come from the west and southwest. And there's a relationship there. The next slide, it's coming from right in here, Jasper Lake, and you can see the dipping thrush sheets dipping to the southwest into that arrow that I've labeled prevailing winds. And so that is really important because it helps the eagles to migrate those great distances. Go to Mount Norquay in Banff and look to the south, and you can see the same thing. There are the dipping thrush sheets, Mount Rundle, Sulphur Mountain, the Sundance Range, and they dip into the prevailing westerly winds. So what's going on? So here is Kananaskis country, Mount Lorette. It's a little elevation profile, a cross section, and I've drawn in wind patterns. They come down the lee of the mountain to the west of Mount Lorette. The winds do. They come down and then they rise up. They rise up because they're following the topography. And those rising winds, and they're really strong winds, create lift or loft for the golden eagles that are migrating. And that provides energy, it reduces the amount of energy that they have to expend to migrate. I think it's a bit of an exaggeration, but one of those sources or references that I read said that because the eagle's soaring in these winds like that, they expend virtually no energy whatsoever. It's almost as if they were sitting still. I don't buy that, but it's really a powerful statement, or it was in my mind. If you want to see golden eagles, you can see them up and down the foothills. Not the foothills, up and down the leading edge of the eastern Rocky Mountains, probably just west of the foothills. And that's what I've shown here in this golden eagle migration viewing localities. Slide in the top right, Roche, Mayette, and Jasper is known as a place to see them. Go down into Crow's Nest Pass, Turtle Mountain is another spot. So there's the relationship between geology and golden eagles. Let's leave the mountains and go into the prairies. Let's look at wildlife of the dry, rolling prairies. This is Iron Springs. about 2 hours southeast of Calgary. And what we're looking at is really a dry climate now in the prairies. And there's a reason for that. And one of the reasons is that the prairies are located in a rain shadow situated to the east of the Rocky Mountains. The Rocky Mountains are contributing to the creation of that dry climate that we see in Alberta, parts of Saskatchewan. So what happens, or what the story is there, is moisture-laden winds coming from the Pacific Ocean off west of Vancouver Island. They blow from the west to the east. The moisture-laden winds rise up the mountain slopes, lose their precipitation. That's why we have rainforests in Western British Columbia. As the moisture cools and condenses, the winds make their way across. The moisture-laden winds make their way across British Columbia, and then they descend the eastern slopes of Alberta, warming as they drop, and that provides increased dryness across the prairies. So as a result, we've got this vast, extensive rain shadow, and that contributes to a lot of the landscape and vegetation that we see in the prairies. Here, if you go to Police Outpost Provincial Park, and you can see Chief Mountain off in the distance in northernmost Montana, you can see right there in this image the change in the vegetation. You can see the forest off to the west or in the distance, and as you go only a few tens of kilometers southeast, it starts to get drier and drier. So that rain shadow, if you look at a Google Earth image, you can see the effect of it with the vegetation. You can see the darker green colors is all the trees of the boreal forest. So the rain shadow is what contributes to the grasslands that we have in the prairies. And to the north, the parkland, the mixed grassland, and mostly aspen poplars. So moving further east into the prairies, that aridity, that dryness promotes the growth of short and mid-height grasses. This is in the manyberries area here. An interesting thing about the prairie rain shadow, we know that it's lasted for at least 40 million years. We know that from fossils and different and certain rock types that we see. We know it from isotopes from 34 million year old horses tell us that the climate was dry 34 million years ago. Soils, fossil soils, 43 million years old, have been recovered from Montana. And that tells us that it was really, really dry then. There were giant turtles around 10, 20 million years ago. They could not withstand freezing. Got nothing to do with the dryness, but says something about the climate. And because of that climate, lots of animals have evolved over millions of years to thrive on the semi-arid grasslands. In this instance, there's a picture of a pronghorn antelope in the rain shadow of the Rocky Mountains. What else lives, or who else lives in the rain shadow? Well, Ord's kangaroo rat. And the story here is Ord's kangaroo rat, drained lakes, and active sand dunes. You go into southwest Saskatchewan, southeastern Alberta, actually many, many places across Alberta and Saskatchewan, and we can find sand dunes. Most of the times they're vegetated, but we do find places where they're still active or where there are blowouts. So that's the habitat of the Ord's kangaroo rat. So why do we have so many sand dunes in western Alberta, in Alberta and then Saskatchewan? Well, during the glaciation, when the ice started to melt, lakes formed up against the ice. And that's what I'm showing in this cartoon. You can see the melting ice. It's moving back to the north. And in front of it is a glacial lake. Well, as the ice moved back, the lakes would drain and the strong winds would blow. Strong winds would create these sand dunes on the old glacial lake beds. So there's the winds coming in again, affecting the story. Those glacial lakes extended all across Alberta and Saskatchewan, and you can see them shown in blue here. And why I show this picture is because as the ice melted and receded back, these lakes formed in front of the ice. The lakes weren't all there at the same time. Their location was dependent on where the ice was as it was pulling back. But look at that pattern of where the lakes were, and then look at the sand dunes. So there are the sand dunes that formed on those old glacial lake bottoms or just downwind of the lake bottoms, which were filled with sand. So that's why we have the sand dunes. If you want to look at Ord's kangaroo rat, we'll head into southeast Alberta, southwest Saskatchewan, and you want to look for sand dunes. In Alberta, go to the Empress area, and you may find them right along the border. Saskatchewan Great Sandhills Ecological Reserve is a great place to go look for them. So here is a picture of the Great Sandhills Ecological Reserve, and you can see the dune shape in the distance, and it's been vegetated. But there are active sand dunes. And so you park in the parking lot off to the right, climb the hill of the first dune. And there's that saying that, well, people wonder where cowboys go when they die. Well, somebody has made this feature here showing where cowboy boots go when they've passed their time. I think that's pretty interesting. Somebody went to all that work. So on the Ord's kangaroo rat, you can see their large feet for hopping on sand. They've got that long tail to assist locomotion in the sand. They need active sand dunes as they hop around. If there's too much vegetation, it hinders their locomotion or their movement. Ord's kangaroo rat, you're only going to see at night. Even if it's a full moon out, there's a strong chance that the Ord's kangaroo rat will not come out. You go out to these sand dunes, you look for them. If you have a large, strong flashlight or your car headlights, they'll probably stop and just freeze in the headlights. Here is on the left the burrow of a kangaroo rat, and on the right-hand side, you can see there is a tail imprint going up from top to bottom of that slide, and little footprints from where the kangaroo rat was hopping along. We'll do a little bit of a digression, but Ord's prairie rattlesnakes, they love Ord's kangaroo rats. They're out at night, they're hunting for, and they will look for the Ord's kangaroo rat. And the reason I bring that up is there's an interesting story here. The Ord's kangaroo rat collects seeds in its fur-lined pouches that you see there. And the prairie rattlesnake loves to catch and eat the Ord's kangaroo rat. But the interesting thing is prairie rattlesnakes cannot digest cellulose. So they will get a rat, an Ord's kangaroo rat, and it'll pass through the snake. You know, basically that's how the snake digests its prey. It just passes passively through the body. Well, the cellulose is not affected by the chemicals in the snake's body, but the moisture in the snake's body will cause some of the seeds to germinate. And a couple of weeks later, 2 to 4 weeks later, the seeds will pass out the end of the snake, and we're spreading germinated seeds around already. So I found that as an interesting seed dispersal mechanism. There's Geology and the Ord's kangaroo rat. Burrowing owls and treeless grasslands. Burrowing owl habitat. It's prime habitat. It's located in the rain shadow of the Rocky Mountains. In eroding badlands, usually the flat tablelands of our badlands topography. They inhabit rolling glaciated terrain. What they're looking for is minimal tall vegetation. They usually will live in they prefer, and historically, they've been in black-tailed prairie dog colonies, which is what you see here. But they will also inhabit Richardson's ground squirrels, gophers, badger holes, coyotes, or foxes. What they do is they'll take over the burrow, in this instance here in this photo, of a black-tailed prairie dog. They will lay their net, they will make a nest, and they will lay their eggs. An interesting thing in this terrain, we also have prairie rattlesnakes. And if a predator enters the burrow of a burrowing owl, the burrowing owl, if it's in there at the time, will quite often make a noise like a prairie rattlesnake rattles to scare any potential predators away. So they require open areas with short and tall grasses for their prey, mice, voles, grasshoppers, and they'll usually travel up to 2 kilometers away. They also need open space to watch for predators coming after them. There's the relationship between geology and burrowing owls. Glacial lake beds, low relief glacial terrain, and tabletops of badlands. Who else lives in the prairies? Pronghorn antelope and the broad open prairies. Their habitat is wide open spaces, gently rolling ground moraine, which is formed by the glacial ice, old glacial lake beds, as well as the dry prairies in the rain shadow again. An interesting thing about the pronghorn antelope is they've got these large eyes set far back on their skull. With those eyes, they can see movement up to 5 kilometers away. And that's a very powerful defense mechanism. And they evolved that defense mechanism because when they evolved at the same time as predators like the now extinct American cheetah, dire wolves, the American lion, were on the prairies, and they would be hunting the pronghorn antelope. As a result, they have burst speeds when they have to dash away, run away up to almost 100 kilometers per hour, which is pretty fast. So geology of the pronghorn antelope, you can see they're in the rain shadow of the Rockies. Their preferred diet is silver sagebrush, which is high in protein, and that's adapted to grow in the rain shadow. Greater shorthorn lizards, horny toads, and eroding badlands. So the greater shorthorn lizard, 10 centimeters, 8 centimeters in size, we find in southern Alberta, southern Saskatchewan, many berries area, Grasslands National Park, and a few other places. But they're pretty rare. They're endangered. They're what's referred to they're referred to as what is a sit and wait predator because they blend in so well with the landscape. They just sit there and they'll wait for ants and grasshoppers, their preferred diet, to come along, and they'll dash out and grab the ants or the grasshoppers as their meal. Their habitat are eroding badlands. South-facing slopes are preferred on those badlands, and they avoid heavily vegetated areas because it's hard for them to move around. They like the remnants of eroding badlands. There's my wife looking for a greater shorthorn lizard in Grasslands National Park. Here in the many berries area, this is just great. These are marine shales from an old seaway that occupied Alberta about 70 million years ago, and they love this type of terrain. They'll quite often be in the juniper right there, where they can get shade if need be, on these south-facing slopes. Fine dining. This is the scats of greater shorthorn lizards, and you can see grasshopper leg on the lower left there, and all sorts of grasshopper parts. They also eat ants, and ants have got acid in their body. Particularly in this instance, what we're talking about is uric acid. So there's the scat of a shorthorn lizard, and the white blob on the left is a pellet of uric acid that the shorthorn lizard concentrated and then defecated out. Bit of a digression here. The loggerhead shrike, carnivorous songbird. Shrikes are the only carnivorous songbirds. They don't have a raptor claw, but they don't have a raptor claw to seize and hold their prey. All other songbirds are not carnivorous like the shrikes are. So what's a raptor-like claw? It's like on an osprey or an eagle. They've got that claw that comes around and they can hold whatever they catch. Well, the shrikes do not have that ability. So what they do, and they do hunt greater shorthorn lizards, is they take their prey and they'll put it on a hawthorn barb or a barbed wire fence. And they do that to store for future consumption and to impress females of their hunting ability. So there's geology and the great horn and the relationship between geology and the greater shorthorn lizard. Let's change topics. Let's look at entrenched rivers crossing the prairies, meandering rivers, cottonwood forests, and prairie oases. Mentioned this before, during the last glaciation about 21,000 years ago, when the ice was at its maximum. It was as thick as it was going to be at the time. Ice sheet covered all of Canada, British Columbia, all the way across to the East Coast. So with all that ice, and let's say in the Edmonton area, the ice was almost 4 kilometers thick. Calgary area, it was about 1.5 kilometers thick. Think of the weight of that ice. And the weight of that ice, it pressed down the Earth's crust. It caused the crust to sink. And so the molten mantle flowed away because of the weight of all that ice load. And then when the ice started to melt, the crust rebounded back as the mantle flowed back into the, let's say, prairies area, but all across Canada. And what happened then is the crust rebounded. Rivers were flowing across the province at that time, or the provinces, and they down cut these deep valleys. Red Deer, you can see labeled there, Red Deer River Valley. And I've got it shown twice because it meanders across the prairies, or the South Saskatchewan River, giving us these really deep river valleys. Here is the Red Deer River at Dinosaur Provincial Park. And what you see, and the point I want to make here, is the prairies are very dry. They're because of that rain shadow effect. They're very arid, well, actually semi-arid. And on this picture, where do you see green? Ignore the irrigation circles at the top. The only place you see green is in the river valleys. Those are cottonwood forests. In this picture, you've got the South Saskatchewan River flowing into the Red Deer River, right at the Alberta-Saskatchewan border. And again, where do you see green? It's only in the river valleys. If you look here, this is the Red Deer River Valley in Dinosaur Provincial Park, and you can just look at this landscape. It just looks dry. It looks arid to semi-arid, except in the river valleys, where you can see where the large cottonwood poplars are growing on the sides of the river. Here is the Milk River and its canyon down in southeast Alberta. And there is that cottonwood forest there as well. Here's the Red Deer River Valley north of Trochu, northeast of Calgary. And where are the only trees? They're in that river valley along the margins of the river. Our rivers, our prairie rivers, typically flood every late May to, not every, but in late May to early July. And they will flood every 5 to 10 years. Here's the Red Deer River during one of the high water stages. It wasn't flooding its bank, but you can see how dirty it is, and you can see the foam as well. Here is the South Saskatchewan River in 2013 when a Medicine Hat got flooded, and you can see how far on the margin on this park, how far the river water went up into the point bar of the park. At the same time that our rivers are flooding is cottonwood poplars are going to seed and dispersing their seeds late May to early July. And they do that, and those seeds to germinate have to land on a fresh seed bed. In that photo, there's probably millions upon millions of cottonwood poplar seeds. Those seeds have to land on sand that's just been deposited by a river that's been flooding. After the river floods, water level drops and sand is deposited. To germinate, the seeds need about a week of moistness in those sands. And that's what I'm trying to show here in this picture. Flood level, falling water level, and then the sand on the right-hand side of the river is great seed bed. What does that look like? In this Google Earth image on the left, you can see where the yellow arrows are pointing to fresh sand being deposited. On the photo on the right, you can see freshly deposited sand and gravel, which is seed bed for cottonwood poplars on the Medicine Hat, at Medicine Hat. So the cottonwood forests across the prairies provide great prairie habitat. They provide refuge for birds, for animals and reptiles from heat, sun, and wind. It is pretty amazing how important these cottonwood forests are to wildlife across the prairies. If you go to Red Deer River Valley and any of the river valleys, any of the river valleys across the prairies, the story is going to be the same. But in the Red Deer River Valley, 130 bird species are reported occurring there, 64 species nesting in the cottonwood forest. Here's a picture of an American goldfinch. Here's a picture of a spotted towhee, again in the Red Deer River Valley. There's a bull snake here. They take advantage of the understory in the cottonwood forest. They do climb trees. When we were in Dinosaur Provincial Park earlier this year, there was a bull snake, and it was starting to climb a tree, and it was going to go after grackles. The grackle nests were there, and it would have been the young fledglings. And so the parents started going after the snake, and probably 15 minutes, 10 minutes, there was 10 to 20 grackles harassing that snake, and he took off, and he didn't get the fledglings. It was kind of interesting to watch. Writing on stone, Provincial Park. In the cottonwood forest understory, here you've got a young porcupine eating the tender leaves of a hawthorn tree bush. So there's the relationship between geology and cottonwood forests, and then the animals that live there. Who else lives in these entrenched river valleys? Western painted turtles do. River floodplains and abandoned channels. Where are you going to find western painted turtles? They live in slow-moving waters with sandy or muddy bottoms. They live on the banks of meandering rivers and smaller streams. They live in the oxbow lakes, which are abandoned river channels in the river valleys, as well as wet marshes. If you want to see western painted turtles, and I will say this for sure, go visit the Elizabeth Hall wetlands in Lethbridge. They were introduced, so they're not native there, but they're in this abandoned river channel, this oxbow lake. There'll be hundreds of them there. And here's a picture of some of the western painted turtles jockeying for position on this floating log. If you go into Saskatchewan, the only natural habitat for the western painted turtle in Alberta is in the Milk River drainage. What happened in years gone by over the decades, people would get western painted turtles as pets. You'd buy them in the stores. Some of you remember that. You get tired of your turtle, and rather than flushing it down the toilet, people would put it in the local river, local lake, local marsh. That's why there's supposedly western painted turtles in Banff, why there's western painted turtles in the Edmonton area, but they were all introduced. Native, they occur in the Milk River drainage. They also occur across Saskatchewan, which is what I'm showing in this image here. So wildlife, landscapes, and geology. The whole premise of what I'm doing and in my book is knowing a little bit of geology helps you to discover wildlife and spectacular landscapes. You know a little bit of geology, you might know where to go look for some animals. So what is in the book? Wildlife, landscapes, and geology. So I got lots of maps. And in this instance, I'm showing wildlife and landscape viewing localities. For instance, if you go to Southeast Alberta and take a look at that 1-4 heritage area, the Kennedy Coulee Ecological Reserve area, what you might see there are golden eagles, prairie rattlesnakes, burrowing owls, greater shorthorn lizards, and a variety of other animals, reptiles, and birds. And in the center column, which I won't go over right now, is a synopsis of the geology there. Upper Cretaceous bedrock, semi-arid rain shadow, help you get out and explore. I put in I'll call it a calendar of when to go look for the various animals. Some animals, like the American pika, you're only going to see in the summertime. Some organisms, like the Banff Springs snail, the best time to see it in Cave and Basin National Historic Site is right now, wintertime to early spring. I won't go into the reasons why. So there's a calendar of the seasons of when you can go looking for different types of animals, birds, and reptiles. I don't talk about the conservation status of the animals. That's another topic, leave that for others. But as I talk about each of the animals that I talk about in the book, I label as what their status is. Are they at risk? Are they safe? And just basically what their status is, so people are aware. Lots of maps, location maps. This is golden eagle migration pathways, where people can go look for whatever they want to see that's in the book. I show the range and occurrences of the different animals. This is the American badger range and occurrences where people have seen it, or some of the places where people have seen them. I do talk about the geology and the animal, whatever animal we happen to be talking about at the time in the book. I've got landscape art in there. Dean Francis put several of his pieces from there. Dean lives east of Empress, north of Leader in Saskatchewan on a half a quarter section of land. And it's really worth going to visit him and his studio. His studios are old churches that were built in the very earliest 1900s, and he's brought three of them to his art gallery. Two of them are galleries, and one of them is a studio, but he's put a lot of his art into the book. Sergio Gaetan, who designed the book, he also put this digital art of the animal imagery into the book as well. So I appreciate that. So I'd like to thank you very much for your time. I'd like to thank the photographers and the artists who put their works into my book. Funding was provided for me to publish the book by the Canadian Geological Foundation, and I'd like to thank them for their support. I'm very good for questions. The book is available in most of the bookstores across Alberta. If it's not in stock, they can order it in for you. So thank you very much for your time.
All right. Well, thank you, Dale. That was a fantastic presentation. First, what I'll do is I'll just stop our recording here before we get to